before getting started, I have a little request for help. While we were at the dinner last night, somebody sneaked my bike chain. And it was I don't know, it was a blue bike chain. It was a special one to me. But if you, they're pretty unique. So if you see a bike around town, just take a photo. I will show you a couple of Python snippets, how you can extract the geodata from that photo, and just send me the coordinates, because I can find these people then and just ask them where they bought that chain. So with that, hi, my name is Hannes. I'm a senior Python developer at CrowdStreet. But today I want to talk to you about geodata and Python. And that's something I learned while I was co-founding a startup called Renewable, where we tried to identify solar potential homes in the US. Why could this talk be interesting to you? Because location is everywhere. When you look at your phone, you look at your privacy settings, there's probably a location tab, and you can set the settings. And basically, as a Python developer, there's a good chance you work as a backend engineer, and you have to deal with that data. So the purpose of the talk is I just want to show you how easy it is, or it's not rocket science to deal with geodata. And there's some tools around like how to deal with that, what databases you can use, and how you can create API endpoints. So basically, the next 30 minutes, quick intro to geospatial basics, how you can geolocate locations, how you can deal with the data, how you can make queries, and then I want to give you a quick intro how you can create an API endpoint. So it's a pretty broad field. And I have to be honest, I'm not the expert, I'm not the geospatial expert, and there's so many things you can talk about, and I only want to talk about a small subset. So just to put this up front, we're getting narrower. Let's start with the geospatial basics, just a few to start with. You should know the difference between an unprojected coordinate system and a projected coordinate system. So an unprojected coordinate system, let's say it's a latitude, longitude system. It's very easy to find just your place, but it's very difficult to calculate the distance between two locations. And that's why there are projected coordinate systems. It's basically a representation of the Earth. One thing you need to know when you encounter projected coordinate systems, they're very location specific. So there's one for Oregon, there's one for the US, there's one for North America. They go even down to county levels. So you just need to know what the ID is and how to deal with that. And the ID is represented by what's called the SRID, the Spatial Reference System Identifier. And there are tons of them. Don't memorize them. There's a cool resource, spatialreference.org. You can just look them up. You can see what the projection is, how you can transform from one to the other one. If you get data, for example, from Oregon that uses an Oregon projection and you want to translate to something more North American-like, then you probably run into the 4326. That's the ID of the most common coordinate system. So if you want to remember one thing of that talk, just remember that ID number, and it helps you translating. Let's talk about projections. When these gentlemen get their security briefings, they probably get the briefings in different coordinate systems. One is the WGS system, and the one is the Chinese counterpart. They're exactly the same, except that there's a 100-meter offset for the Chinese one. And certain, I don't know if you intend to work on an app for China, but if you release something for China, you have to use the coordinate system. So if you work on a Google Maps app and it's supposed to run in China, you have to load a special package which translates everything into the Chinese coordinate system. The good news is GPS runs on the WGS system. So if you get GPS data, that is already in that coordinate system. So what data can you use? You have a couple of formats you can use. It's raster format. It's basically maps are in the grid system. You have data points or like color schemes that represent data points, and they're the tools which load this raster grid and which basically pushes it into your database. You can use a vector format where you can have points, lines, polygons, which represent geospatial entities, and you can give values to them. And I will show you an example of how you can load them into the database. In other formats would be KML or GeoJSON or simply JSON. So it's not rocket science. How do you store the data? There are a bunch of options. You can use SQLite if you want to run something locally. If you plan to run something production, I highly recommend to go to Postgres. It's just the de facto standard. Why is it the de facto standard? Because it comes with a wonderful extension of PostGIS. And the amazing thing of PostGIS is it adds the geospatial functionality to the database. So imagine you have a normal database, you have a list of city names, and you say, hey, I want all of the city names starting with an A. That's something you can do with a SQL query. If you have PostGIS installed, then you can say, give me all the cities within the polygon of Oregon, for example. And you can do the queries on that. Some useful tools before I'm getting into the Python details. One amazing tool is QGIS. It's an open source tool. It helps you to look at data, to look at raster formats, to look at shapefiles. You can actually connect it to your Postgres database remotely. It's a wonderful thing. It's amazing. Another tool we have used at Renewable is CartoDB. It's sort of an online service. You can dump your data in it, and it generates maps for you. And if you pay for this service, you can even do like analytics on the geolocation of Twitter feeds. So you just dump a hashtag in there, and it shows you where they're coming from. But you don't need to pay for it. At the end of the talk, I will show you how you can do that without that service. Enough for the basics. Just one very last comment. You're dealing with privacy data. Just be aware of that. If you write an app where people upload their photos or their running tracks or something, that you see common behaviors. So basically, be aware that that's basically dealing with passwords and things like that. What sources of geodata can you use for your project? The most obvious one is you can geocode addresses. And when you type in geocoder for Python at PyPy, there's like gazillions of packages. And the one package I would highly recommend is called Geocoder. The reason why I really like this package, it supports 20 different services. And that becomes very useful if you work in an area where Google might not be the best option. That Geocoder supports like Baidu if you have a Chinese project, or they use a UK geocoder which can deal with UK postal codes, which is sometimes not the easy thing. And it has some nice features. It does reverse geocoding. It does has like a command line interface, and it exports different data structures. If you have your addresses geocoded, you can spit out GeoJSON. The usage is super simple. You basically load the package. You define what geocoder you want to use. In that case, I want to use Google, and then I get the latitude and longitude. It also supports reverse lookups. You can put in the latitude and longitude, and you get the address back. The nice thing is with the geocoders, they will normalize your address. So even if you misspell your address, you probably know this from Google Maps, you misspell your address, you get it in the US Postal Service corrected format back. So that's really nice to normalize addresses. Another option to get geodata is by geolocating the IP. It's something you can do with the same package. You just put in the IP from your user who goes to your website, and it gives you the location of the closest node. Very, very handy. Another thing which is a great input for geodata is using images. You probably have seen this on like Instagram. You upload a photo, and it tags the photo with a certain location. And every photo taken by a camera with the GPS functionality, which is usually in every cell phone, provides tons of data. So it's not just the latitude and longitude. It provides the altitude. It provides the speed. It provides the direction of the photo. You can extract tons of information from that one. And there's a tool, it's PyDX, which stands for exchangeable image file format, and you can read a lot of metadata from the image. So far we only talked about like points. Let's say you want to add some lines, streets, polygons, which could be counties, cities, etc. And you can use shapefiles for that. So that's an example of a shapefile for the counties in Oregon. And it's really easy to obtain shapefiles. You look up sources like Civic Apps, or there's a lot of open source data floating around. One great resource for Portland is the Portland Atlas, and it's a compilation of almost every available shapefile for Portland. It's like location of trees, streets, it could be bus routes, it could be there's garbage pickup routes, everything you can think of. And somebody assembled this amazing repo which is doing this job of normalizing the data for the world's coordinate projection. Because the data often comes in a unique projection, but you don't have to worry about it. An amazing tool comes with Django automatically. That's called OGR inspect. And when you have a shapefile, you can run this command. Don't worry about the output, but you can run the command, and it will read the shapefile and generate a model for you. Because at some point you have to store all the data in your database, and you probably have to write a model for it. But Django does that for you already, so you don't have to type it. If you handle a shapefile, just remember that command. Highly recommended. How do you load the shapefile into the database? Don't worry about all the code, because Django is doing that for you. So this is an adjusted code snippet from the GeoJangle tutorial. You can basically copy paste it if you use the Portland Atlas, and it will load, in this case, the neighborhood shapefile into the Postgres database. And it does all the mapping, etc. So you don't have to worry about it too much. Just remember to get back to the presentation or the GeoJangle tutorial. So the big thing is, what can you do with the data? And I can think of a couple of static applications. At some point, you probably manipulate the data. You want to find out what's your favorite. I don't know if you look for a house or something. You want to get it close to a bus stop. You can export all these points to a KML file. Again, it's not rocket science. You basically, there's a wonderful package called Simple KML. You export all these points. In this case, I export the neighborhoods in Portland. You define your outer bounds and inner bounds. If you don't define your inner bounds, you basically get like white surfaces. And the result looks like this in Google Earth. So these white lines are basically the borders of the neighborhoods in Portland. Another application is, let's say you have a data set of users and you want to figure out where they're living, and you want to generate like static maps. You don't want to go to Google Maps and do a right click and say, you can automate this very easily with a tool called Motionless. It's a very simple package. It runs on Google static maps. And this is basically a two-liner. You define the address, you define the map, you add a marker on it. You can even skip that. And the rest down here is just to download the image. What the package does, it generates the URL to download the static image. With all these packages, with all the geocoding and generating maps, etc., you have to be careful using third-party services, and they often have rate limits. So you cannot geocode 100,000 addresses in a day. Somebody will ask you to pay for it. So either you find a way around it, or you just split it up, or you generate a bunch of keys and rotate the keys. So if I use the tool to geolocate our building here, that's what I get in return. But this is all static. So now the interesting thing is, how can you do dynamic queries? Let's say you have a list of all coffee shops in Portland, and you want to find out what's the closest coffee shop. So you have geolocated all these locations, and you want to query your database. You can do this easily in GeoJangle because it adds the geospatial functionality to the normal ORM, you know, from Django already. You get a bunch of additional fields. So you can store points, you can store lines and polygons, and the multi-variations of it. And then it allows you to do crazy queries. You can figure out, hey, give me all the points which sort of overlap with a certain polygon. give me all the ones which touches the exact border of a polygon. So to be honest, I haven't used all of them. I've used a small fraction of these query sets, but already they served all my needs. Another amazing thing is you could do distant lookups. You can say, hey, I have this location, give me all the coffee shops in a 1 mile radius. And GeoDjango supports that, or it basically goes to PostGIS and translates it into query. So these are your distant lookups functionalities. I would like to show you two simple projects where I use the functionality to just show you that it isn't rocket science, and it's like very easy to get started on these projects. The first project I want to show you is a simple geomodel, and I would like to demonstrate the additional functionality for the admin in Django, which is already a nice tool, but if you connect it with the Geodata, it adds a lot of functionality. I want to just show you simply how you can save at one location and how you display it. So at the end, we end up with a tool like this. It's just a simple project where you record emergency calls in Portland. It could be coffee shops or anything else. So you know the general model, you just have to make two tweaks. One is you use the model field of a point in this case, because I want to store the emergency calls where they come from. And I have to override the manager because I need to add the functionality of like doing all the geo queries. And then the code snippet down here is basically I get the location from somewhere. In this case, I geocode it. So there's a little input line where somebody can type the address, and then I shoot it to Google, get the address back, or get the coordinates back, and then I store it in my database. And there's a function called fromString, and I turn it into a location. In the view itself, I just say, give me all the locations within a certain neighborhood. We will see the functionality in a second. There's an option where I can say, hey, give me all the calls originated from a certain neighborhood. And that's basically the query I need to do. I take the polygon and I say, I want to get everything within the polygon. And then one of the last changes you need to make is updating the admin so that you get the geo functionality. And you basically override the admin functionality. You load the class for the OpenStreetMap display, and then you have the option to add some additional functionality like the zoom level, etc. And when you do that, you get this amazing functionality. So instead of displaying the string of the polygon itself, it will be translated into a map, and it actually shows you the polygon. So this is like the polygon for the Portland downtown neighborhood. On the client side, this is a little bit of a JavaScript snippet. Again, this is not crazy. This is basically an array in JavaScript, and I sort of loop through the list with the Django loop. It's crazy, but it's not like rocket science again. But it ends up to be this project. So let me try. So here this is so I don't know, I can add this functionality. So I didn't specify a certain call, but if I then say give me everything, so I get these 2 points. Unfortunately, I use the same address, so that will work. But this is that's. That's just me typing. In this case, I'll show you.
You made it up.
I made it up. There's no calls. Yeah. And the next example then I'll take, but yeah. So this one is just there could be coffee shops, convenience stores, could be anything. The one data I received is basically the neighborhoods of Portland, and the data originates from the Portland Atlas repository. All right. Okay. So in this case, that's a typical Django site, and you have to, every time you submit something to the site, you submit at that point, or you change your neighborhood, it has to reload the entire site. So you might end up in a situation where you have a JavaScript client and you want to provide a REST framework or a REST endpoint, especially when you also deal with mobile data. And one way you can work with that is the Django REST framework, which is an amazing package. I don't see it as a Lego Technics thing and Duplo comparison. So, yeah, it just adds a lot of wonderful functionality. And I have a second project I would like to show you how you take this current project I just showed you and you turn it into an API endpoint. I just want to show you it's not rocket science and it's not something crazy. And then at the end, I want to show you something small, useful. So that's the project I created for this talk. And this is actual data. This takes a look at the Portland police Twitter feed and basically takes all the calls, geocodes them, and then creates this little screen for me every time you hit the website. So it's actual data. So if somebody wants to try it out, you can call the police now. Not recommended. And there's also a delay of 20 minutes, so should have made the call here. So what do you need to change in the code from the existing projects? In the model, you don't need to change anything. So just to create an API endpoint, obviously, nothing crazy. You have to create a serializer. It's done by this Django REST framework package, which is an amazing package, but it comes with an addition or an add-on which supports the GIS data. And in this case, again, you override the normal serializer and you define what type of geodata it is. In this case, it's a point. It's a single point of location. And the reason why you want to use this add-on package, if you use the normal Django REST framework or TastyPy or whatever you prefer to use, the location coming out of the database will be in that string block. And you probably don't want to parse that on your client side. You probably don't want to script like the SRID and then the point and figure out its latitude. If you use the add-on, it creates an additional field, which is very handy. What do you need to change in your view? It's an API endpoint, so you can sort of discard the whole view compilation, and basically you just provide a serializer and somehow this model equal call location props. But this would be just a two-liner. The crazy, or not the crazy part, but sort of the most changes you have to do is on the client side, because in that situation when you have a REST framework, you probably have a single page application. It's a Python conference, so I don't want to get into these details, but you can use an Angular directive, which is basically map, and then you pass in the markers. If you're interested in that, all the code is on GitHub, so you can take a look at it. The code up here is basically making the API call and then pushing it into the map. If you do that, you will end up with something cool. You're supposed to end up with something like this. It pulls the calls from the Twitter feed and then puts them on a map. And you can basically zoom in, zoom out. The one thing you want to be careful of with all these like data points, when somebody looks at a map and it just looks at a certain zoom level and a certain neighborhood, you don't want to load the whole database. So there's one thing I want to show you how to easily restrict that. There's a simple way to do that so that you only get, I don't know, 7, 8, 10 points and you don't query the whole data. the data, or query the whole database. The way you do that looks like this. So how can you limit the API request? You can add Django filters to that, and it works really nicely together with the add-on for the GRS functionality. And what you do is you just basically add the line filter backends. That's all you need to do. Because what you then do is, on your client side, you sort of try to find out what's the map size, and you can read the map. In this case, I'm using standard Google Maps. You can read the boundaries of the map, and you pass it. You generate a string, and you pass it as a query. So the query to the call to the API endpoint looks like this. The boundaries are basically just a parameter. But I have to say, I haven't programmed anything here. I'm just reusing functionality existing by using the Django filters. And with that, you can switch back to that. I'm stuck here. Anyway, with that, let's recap. I showed you how you can do SRI, or what SRIDs are. Remember the one number, the 4326. Showed you a couple things, how you can use, how you can generate geodata with Python, how to store it, how to query it, and the API endpoint. A couple wonderful resources I used. There's a great book by Eric Vestra, Python Geospatial Development, and it talks about all the other things I haven't mentioned in this talk, like how you do how you deal with certain packages, like Geodata, how you use MapNet, or how you run your own tile server. So very useful. There's a bunch of amazing talks about geodata, and I highly recommend the tutorial of the GeoDjango if you're interested in that. That's a great example. Rob Story had a talk, or has something on his blog about using D3 with geodata. I think that's amazing. Beyond that talk here, and then also a bunch of DjangoCon 2014 talks and PyCon 2014 from Melanie here in Portland. She looked at some other parts of the amazing field of geospatial. A couple other tools I really like to use if you need fake addresses, because they have to exist at some point, because you want to geolocate them, so they have to be. You can't make up an address. There's a cool tool. The Portland Atlas is a really wonderful resource for local data, and then the Boston GIS group. I recommend it. And yeah, this talk wouldn't have been possible without wonderful friends who helped me to prepare the talk, and thank you.
Okay, great. So there's about 10 minutes for Q&A. So I'll have Hannes field them as he wishes.
What was used before Python Geodata?
The question was, what was used before GeoDjango?
Yes, before Python and Django were doing Geodata. What was used before?
In terms of manipulating, or in terms of like querying?
Storing information and manipulation.
It's a good question. Anybody? I have a guess, but I think I'm probably wrong.
GIS. Probably, right? That's the only.
Yeah.
So for your when you were doing the Twitter, were you just pulling from the screen?
Yeah.
Were you just like, what were you doing to pull location data before? Like, were you just searching for like close near a certain latitude or longitude, or how?
No, actually, for this one, I can show you that. So So the Portland police log, it basically just parking problems. It's a very standardized format. So it says first what happened, where it is. It takes always the midpoint of the block, of the street block, and then some other stuff like. Let me get this. So there's some, yeah. So I just parsed the thing. So I just took the string and then parsed the data out of it. When you deal with Twitter data, a Twitter stream, you can actually they geocode the data for you already. So if you take a look at the stream itself, they'll find out where the tweet was from, and then they find the closest location to the actual content, which I found really strange. Like for example, the Portland Twitter log, or the police log, it had the location of the occurrence of the call, not where the Twitter feed was from, which I find spooky. But
I was noticing that only like a very, very small percentage of tweets actually came with geodata. So when I was looking recently, I was looking for some random Portland tweets. There were only just a handful compared to like if I searched Portland search term. So I was curious if you were just looking at this police Twitter, if you were looking for other Portland tweets, what's your approach? Just to like do a big blanket search.
Yeah. If the data is not in the stream, I think it's very difficult to reconstruct that unless you have an address in there. I think if it's sent from a phone, then it uses the geolocation automatically, or unless you have it enabled or disabled.
So you talked a little bit about geocoding in particular, and I know that a lot of the big providers of geocoding APIs have a lot of other place-related APIs, things like routing and traffic and locations. Do you know of any good Python libraries to wrap those various other functionalities?
I haven't looked into traffic. It wasn't a problem I had to solve because we tried to geotag basically houses. I have to pass on that.
Tom, I actually wanted to field one of the questions I was asked earlier. I just wanted to look some stuff up before try to answer what was used before Python and GeoDjango. Three main systems. Obviously, proprietary
ArcGIS.
Yeah, ArcGIS. Map server, which was proprietary, got open source. And the first open source one was something called GRASS, GRASS, which is still around. Still updated by the OpenGeo Foundation.
And I think it's still a prerequisite to install for some of the GeoDjango functionality.
Yeah. So GRASS is basically middleware. So, but there's a separate stack on top of GRASS for web stuff that came with it. I think it's Java, but I'm not sure.
Sorry, I don't know the answer to that one, but yeah, that's a good thing. There is. In the industry, it's often also used ArcGIS, which is sort of the proprietary Esri thing. I haven't really found out why they use it. I guess it's just somebody started with that at some point and they can't really move away from it. Yeah.
Okay, with that, joining us